Okay, today we're going to do 4.3. So we're going to be solving inequalities, kind of simple inequalities. So this first one asks, if x plus 24 is greater than or equal to 31, then which of the answers here are valid? And all you have to do is plug them in. So if we stick 8 in there, 8 plus 24 is 32. Is 32 greater than or equal to 31? Yes. What about 12? 12 plus 24 would be 36. So yes. 3 plus 24 is 27. That one would be a no. And 7. So 7 would give us 31 is greater than or equal to 31. And because the equal sign is there, yes, that one does work. All right, look at number 2. So solve the inequality for u. So we treat this like an equation. And if I had, if it said 18 equals u plus 8, then I would subtract 8 from both sides. And that's what I do over here. Subtract 8, and we get 10 is less than or equal to u. Now, there is one thing you have to be worried about, and let's see if any of these do it. Not there. Not there. Not there. Okay, what would you do here? Divide by 7, and you would get 8 is less than x. Okay, what about this one? Divide by -3. Now, something weird happens in this case, so let me see if I can explain it here. Yeah, something weird goes on. So, if I had x plus 3 equals 7, and some of you are working ahead, you want to watch this, because somebody probably told you the rule somewhere along the way, but you don't understand why the rule applies. So x plus 3 equals 7. Imagine that this was a balanced scale. So you know those, anyway, those little balanced scale things you used to play with? So on one side, we have a box that says x, and then we have 3 1-pound rocks, and on the other side, we have 7 1-pound rocks. And I want to know how much does the x box weigh? Well, I'm just going to reach in and remove these 3 rocks. But what happens to the balance when I do that? Now we're tilted to the right. So to keep the balance in effect, I've got to go through and remove 3 of those rocks. And now it's balanced, and I have 4 1-pound rocks on one side and the x on the other side. So we're balanced. Okay? And that's essentially what we're doing when we subtract 3. And then I get x equals 4. Okay? Well, what if I had 3x equals, we'll say 6. What does that look like? Well, we have 3 x's, and then we have 6 rocks. So what should I do? So you guys are working ahead. Don't work ahead. You'll want to pay attention to this. Well, I can get rid of 1/3 of everything, right? So I keep 1 and I throw out 2. So keep 1, throw out 2. Over here, keep 1, throw out 2. Keep 1, throw out 2. And I'm left with an x box is equal to 2 rocks. X equals 2. Okay. All right. What about this? How do I represent that? So this is a little bit weird. I have an X, and I have 4. Yeah, how do I do -3? That's one way to do it. It's not the way that I'm going to do it. How do I take 3 pounds away from the left side? And the answer is we're going to put a balloon on there. And that balloon is pulling up the weight of a rock. Does that make sense? So, how do I fix this one? What do I need to do? Well, I need to cancel the balloons. So how do you cancel balloons? You could pop them, or I could put a rock for every balloon. And then what happens here? If I have 3 balloons and 3 rocks on the same side, then it's equal. There's no weight happening in either direction. Okay? So balloons pull up, rocks push down. And the reason I'm saying that is because what if we had this? What does that look like? It's a scale, right? But there's something different about this scale. It's not balanced. You guys understand that? So it looks like this. And on the left side, I have an X and 2 rocks. And on the right side, I have 4 rocks. So, how much does X weigh? Tyson, you're working ahead again. We don't know. But we can get an idea by subtracting 2. Right? And I get X is greater than 2. And if I remove 2 rocks here and 2 rocks here, how much does X weigh? Not 2. 2 won't work. Anything bigger than 2. It could be 3, it could be 7, it could be 100, it could be 1,000,000. Do you guys get that? There are an infinite number of correct answers. Okay, what if I changed that to an equal to? What does that do? It could be equal to 2. Okay. All right. So we're almost to the part that I'm the thing that you need to learn. What if I had 2x is less than 8? So this is unbalanced to the right. What do I do? There are 8 circles. How do I figure out what's going on with x? I just get rid of half of them. Get rid of half of the x's, and I get rid of half of the rocks. And I'm left with x is less than 8. Or, sorry, 4. Okay? Now, everything up to now has worked exactly like you think it's going to work. But we run into a problem when we do this. Okay. So, we divide by -3. and I get x is greater than -3. Okay, let's look at the balance and see what happens. Am I heavy on the right or am I heavy on the left? I'm heavy on the left. Like this. So over here, there are 9 rocks. And then on the left side, what do I have? I have the opposite of 3 x's. Okay? So I have these x's. I have 3 x's. And which way are the x's pushing, up or down? They have to be pushing down. Why? Because the left side is heavier than the right side, right? So, if the x's are pushing down, and I am doing the opposite, are the x's balloons or are they weights? Well, so here, they're balloons, right? But if we do the opposite, then they're weights. Okay, so we have weights pushing down, right? And on the right side, we have rocks pushing down. When I divide by -3, I have to do 2 things. I have to get rid of 1/3 of everything. Tyson, you're doing it again. Right? I got to get rid of 1/3, and what else do I have to do? I have to turn all of the weights into balloons and all of the balloons into weights. That's what a negative would do, right? So I get rid of 2/3. So keep 1, throw out 2. Keep 1, throw out 2. Keep 1, throw out 2. What does my new balance look like? What's on the left side? An x that's pushing up or down? Well, it was pushing down here, but when you divide by a negative, now it's an x balloon. Right? And what's on the right? 3 balloons. Okay? Now, that picture is wrong. Why is that picture wrong? Okay, good. Say it. Right. If 1x is heavier than 3 rocks, then when I switch it to balloons, the x pushing up is stronger than the rocks pushing up. So what happens? We have to switch the inequality. Do you guys see that? Why don't we do that with equal signs? Equal sign is balanced. Whether you have rocks or balloons, right? If you have rocks on one side and rocks on one side and it balances, and you turn them into balloons, is the equal sign still going to work? Yes. So that is a really long explanation to say this needs to be flipped around. Now, when do we flip the inequality? Okay, right. So which problems do we flip the inequality for? When I divide by negative, and it turns out the same is true if you multiply by a negative. So if we look at this, so here I divide by -3, and I get a -4 on one side, and I get a W on the other side. But because I divided by a negative, I need to switch the inequality that way. Why do we do that? Because the picture is unbalanced. One of the sides is already heavier than the other. And the negative turns all balloons into weights and all weights into balloons. And when that happens, then the scale has to flip the other way. Okay. So what should we do here? How do we move a negative 9 over 8? We just times it by negative 8 over 9. And the negatives cancel, the 8's cancel, and the 9's cancel. And over here I do negative 8 over 9. And it's just going to be negative 8 times 12 divided by 9, and then simplify that fraction. But because I did a negative, I need to flip the inequality the other way. Okay, I think that's everything. Get to work.